To graph inequalities, we start by graphing the equation. So I've given the equation here that y is greater than or equal to 2x minus 3. We're going to ignore the inequality part for a second. And by inequality, I just mean that this says greater than or equal to, it doesn't say equal. I'm just going to graph the line, 2x minus 3. So we start with the y-intercept as negative 3. The slope is 2, so rise is 2, run is 1, and we graph that like this. So there's my line. Now, I said greater than or equal to, and I would often kind of think about, okay, greater than, that means, bigger, so you should be able to maybe think, okay, we're talking about this part up here, the part above the line. I guess I should extend my line maybe like that. This stuff, the stuff that's above that line. Okay? And I think that's a fair way to go about this. I always check to make sure I shaded the right part. And I always do that with a point. And I pick a point that is in my shaded region. You could also pick one that's not. But I like to pick the origin, 0, 0, because it's an easy thing to check. And by that I mean the origin, x is 0. So I say, okay, what if x were 0? And at the origin, y is also 0. So 0. Basically, does this make a true statement? Well, of course, 2 times 0 minus 3 is negative 3. Is 0 greater than or equal to negative 3? Of course, the answer is yes. And because the origin made a true statement, I should be shading on the origin side. If that had made an untrue statement, then I would have shaded, in this case, on the incorrect side. But you should be shading on the side of the true statement because, of course, we're trying to shade on the part that works. Let's do another one. So in this case, I said that y is less than or equal to 4 minus x. So let's begin by just graphing the line 4 minus x. It has a y-intercept of 4, and the slope, well, no coefficient is written. We could add one in and say the slope is negative 1. So it's going to look something like this. I'm going to just extend that down. Yeah. And again, I don't think there's anything wrong in looking at the inequality and saying, okay, this says less than. So it feels like I should be shading below the line. And let me add that in, and then we'll check and make sure that we're correct in doing that. We should be shading. And what we're doing here is we're shading the entire region where this is true, where the y values will be less than or equal to 4 minus the x value. Okay, so we're shading where is this true. Now, let's check a point. Again, I like to check the origin. The only time you can't use the origin is if the line that you're graphing or equation you're graphing goes through the origin. Then you'd have to pick a different point. But again, makes it easy because x and y are both 0. So I could say, all right, 4 minus 0. Y is also 0. So we check this. Is this true? Well, 4 minus 0 is 4. 0 is less than or equal to 4. So that is a true statement, and I should be shading on the origin side, which I had already done. Now, before I do one more example, let me talk about a slight change we could make to our inequality here. Let me just delete my little check. Let's say that instead of saying y is less than or equal to, I just said less than. Okay, so I didn't say it could be equal to. Here's what would change. We would go to our line and we would make it a dashed line. And the dashed line means that this particular line is the boundary of my shaded region, but it is not included. It is not part of my answer set. So if there's an equal sign here, if it's less than or equal, we have a solid line because answers along that line also make a true statement. They're the equal part of it. If we don't have an equal sign, then we put a dashed line saying, okay, all of the stuff that we shaded works, but the stuff on the actual line does not make a true statement. Okay? Let's do a different example, but this time let's go in standard form. So I've given 2x plus 3y is less than 12. Notice it's not an equal to, it's just less than. So our line that we graph will be a dashed line because the line will not make a true statement. The side we shade will. All right, my work with graphing inequalities says that it's easiest if you start by saying if x were 0, what would happen? Well, 2 times 0 plus 3 times y less than 12. Again, I would just think about making it an equal to, but of course 2 times 0 is 0. So if 3y equals 12, you'd divide both sides by 3. And you'd say, okay, so y is 4. So I'm going to put a point at x equals 0, y equals 4. Oftentimes, when you get really good at this, you can almost just say, okay, if x were 0, kind of hold your hand over this and solve. Now, let's do the same thing with y. Let's make another coordinate where y is 0. So we'd have 2x plus 3 times 0 less than 12. So that's gone. 2x equals 12. Divide both sides by 2, and we would have 6. So it's this point right here. And now, because we have the 2 points, we can make the line. Let me add in this dashed line. All right, there's my dashed line. Now, the inequality says less than. So I'm going to shade on the side that I feel is a less than, which would be below. Get my, like down here. And then again, I want to check a point, okay? So let's check 0, 0, see if it makes a true statement. So 2 times 0 plus 3 times 0 less than 12. Well, of course, 2 times 0 and 3 times 0 is 0. That is less than 12. Makes a true statement. So I'm correct in shading that side. So kind of the points here are, first, just graph the line. Just don't worry about the inequality, graph the line. Next, as you graph the line, this is the time to say, is it going to be a dashed line or a solid line? If I add an equal, it's a solid, okay? And just to mention, maybe with an example of what I'm talking about here, if I were to think about this point on the line, this first point I got, 0, 4, 2 times 0 plus 3 times 4, that's 12. 12 isn't less than 12. So that's why we'd use a dashed line, because the points on the line don't make true statements. But if it were equal to, well, then 12 is less than or equal to 12, and that's why it's a solid line. After you do the line, go back to the inequality, make a judgment about shading. I'm going to shade below. It was a less than, but then check. Make sure you shaded the right side. Pick a point on your shaded side and see, does it make a true statement? Okay, plug the origin is easy, but you can pick any side over here and it would work. And I guess the other point is you could pick a point over here and verify that it isn't true, which would also tell you you shaded the correct side. If this video helped you, please like and subscribe for more math help.